You are watching the Unit 2 Lesson 8 video on transforming functions, Day 2. As you remember from the previous lesson, we were doing a lot of work with moving and reflecting and transforming functions. And we are just going to continue with that in today's lesson, only we are going to look at things maybe from a different perspective, but really nothing is going to change in terms of what is happening with the function. So if we recall from the previous lesson, if we change the value that's outside of the function, so the constant, this value right here, what ends up happening is the function is either moved up if it's positive or down if it's negative. If we change the value inside the function notation, what will end up happening is that it will either move left or right. Left if it's addition, and then right if it's subtraction. That's a little backwards, remember that one. And then of course, changing the coefficient has a few different things. So not only can a negative flip it over the the x-axis, but if it's a whole number, it becomes thinner because the slope or the rate of change increases. And then if it's a fraction smaller than 1, the graph actually becomes wider because the rate of change decreases. So let's take a look at some of the examples down below. And the directions say to describe what changes will happen to each parent function based on what you know about functions. And it says if you're unsure, we can always use our calculator to check, which is always nice to know. So of course, question number 1 tells us that we're dealing with a linear function here. Hopefully you recognize that this is a linear function. And part A, only one change has happened to this linear function. It's not an x anymore, it's a 3x. So it's a number in front of the function, x, and it's a whole number. So if we look up top, I guess I should have this up for a little bit for the first one, we can see that it is a whole number, so the graph is going to become thinner. Or in this case, because it's a linear function, it's going to grow at a faster rate, so the slope will be steeper. Continuing on to B, we have x plus 7. So what has changed from x to be x plus 7? Well, a number was added on the outside. So because of that, this is our constant. What ends up happening is that it's positive, so we're moving up 7. Part C looks almost the same as B, and except we are not adding 7, we're subtracting an 8. So this, of course, will move the function down 8 spaces because it's negative. And lastly, part D, we can see that x became a third of x, so we're looking at the coefficient. It's not a whole number, but it is a fraction smaller than 1, so the graph becomes wider, or in our case, because this is a line, it won't be more steep, it'll be less steep. Okay, so that's how those transformations look with a linear function. Let's move on to the quadratic function, number 2. So it looks like we were given the parent function, which we should already know, but they gave it to us, yay. Part A looks like we're adding a 5 to the outside. So what does this mean? Well, it means that the function is going to move up 5. Next, for part B, it's very similar to part A, only we have a minus 2 on the outside instead of a plus 5. So you guessed it, we are moving our parabola, we're moving our quadratic function down 2. Part C, this one's different. It looks like we have the plus 6 attached to this x. It's almost like the x now has a little partner, a plus 6, and all of that is being squared. So if you remember, this is inside the parentheses, so it's either going to move the function not up or down anymore, but left or right. And since it's a positive 6, many of you might think it will move it right, but if you check this on your calculator, it actually does the opposite. It's so weird, but it's going to move it 6 left. In D, we have 3x squared. So x squared became 3x squared. There's now a 3 in front. And since it is a whole number, what ends up happening is the quadratic function, or that U shape, actually becomes thinner. If it had been a 1/3, it would have made the parabola wider. Okay, onward to 3, the absolute value parent function they gave us, which is great. So what we're trying to see is how do parts A, B, C, and D change this absolute value. So what looks different? Well, it looks like there's a +2 inside the function, not outside. If it were outside, it'd be hanging out somewhere over here. So inside, remember, is either left or right, and since it's +2, it's going to move 2 to the left. Part B, now we see the number on the outside of the function. So is it going to move it up or down? Well, it's negative, so it will move it down. So down 4. Part C, we still have a number on the outside, only now it's positive, so we're adding 3. So we're not going to move down like we did in part B, we're going to move up 3. So what we did with this absolute value, that V-shaped function, is in A, we moved it left 2, B, we moved it down 4, C, we moved that V up 3, and D, we have a 1/2 as a coefficient. So what does that do? Well, it's either going to make it wider or thinner, and because it's smaller than 1, it will make it, you got it, wider. And the reason that this happens is because the slope is becoming less steep, therefore making the two V's, or the two parts that make up the V, wider. They're a little bit more spread out. I hope that you're getting the hang of this by now, but now we're moving on to a different function, and really the same rules apply. So what's happening in A? Well, we have a +5 on the outside. B, there's a -2 on the inside. C, there's a +7 on the inside. And D, there's a negative on the outside. So pause the video, answer this question yourself, and check back to see how you did. Okay, so here are the answers for question number 4. Remember that square root function almost looks like half of a parabola on its side. So it looks something like this. And what we do with that absolute value function in A is we move it up 5, B right 2, C left 4, and D we reflected it over the x-axis. Let's move on to question 5. Here we have a cube root function. With this one, looks like we're adding a 1 inside the function. Part B, we have a negative outside in front. C, we're adding 8 to the outside of the function. And D, we're subtracting 4 inside the function. Pause the video now, answer parts A, B, C, and D, and see how you do. Okay, so here's the answers for A, B, C, and D. Just a quick little helpful tip. Remember, when it's inside, it always does the opposite of what you think. So if you had right 1 and left 4 here, just be very careful. All right, number 6. This one is a little bit trickier because it's sometimes hard to see what's considered inside the function and outside. So let's talk this one over before I let you do this on your own. A has a negative out in front. I hope that we all can see that one. B, there's a +6, so we're adding to the outside. C, it's a -1, so we're subtracting 1 on the outside. D, this is where things can get a little tricky. We have an x -3, and that's considered inside the function, like what we did up here in A and D. So go ahead, pause the video, answer A, B, C, and D on your own. Okay, so here are the answers to number 6, A, B, C, and D. Okay, moving on to 7, last of this type of question. we're dealing with the cubic function. And this one's very similar to the quadratic that we saw on the previous page. So I'm going to let you free to do this question on your own. Pause the video, check back with me when you're done. So here are the answers to the cubic function. So A, we moved right 5, B, up 10, C, we made it wider because of that fraction that was smaller than 1, and D was made thinner because of this whole number here. Moving on to wrap up the lesson, we have 4 more questions, and the directions tell us that each function is 2 or more transformations of the parent function. So in questions 1 through 7, it was only 1 transformation. So what we first need to do is identify the parent function and then describe the transformations. So let's look at 8. What function do you see? Well, I see an absolute value, so yes, this is an absolute value function. And why does this not look like the parent function? F of x is equal to the absolute value of x. Well, there's a 3 out in front and a -5 on the outside. So what do you think is happening? If you are guessing that it is going to move down 5 and then become thinner, you are correct. And it doesn't matter what order that you write it in. We could say thinner and down 5 and it would still work. Looking at number 9, what function do you see? I see a square root, so yes, this is a square root function. And how do you think this is changing? Well, it looks like we have a -1 inside the function and a +4 outside the function. So if you're guessing that the function moved up 4 and to the right 1, you are correct. And the order doesn't matter. I wrote right 1 and up 4, but you could have written up 4 and right 1, and it still is correct. All right, pause the video. 10 and 11 are on your own. I want you to think about first what the parent function is. I'll give you a hint for 10 and a hint for number 11. And after that, describe the transformations. 10 has 2 changes, but 11 actually has 3. Hopefully you can find all of them. So here are the answers to 10 and 11. 10 is a quadratic function that's moving right 4 and up 1. So that parabola, this U shape, is going to be moving right 4 and up 1 from the origin. And number 11, this is a cubic function. And remember I said 3 changes, so here's our reflection over the x-axis. Here's our left 1 shift and up 8. So I hope you did well. There was a lot of independent work on this one. If you just copied down my answers and didn't do the work yourself, you probably hurt yourself a little bit because you lost all that practice. But if you're really struggling with this, please make sure you ask questions in class, especially when we're going through the practice. I want to make sure that you know what you are doing with all these different types of transformations. Nice work.